Japan has launched its first osmotic power plant in Fukuoka, becoming only the second country after Denmark to generate electricity from the meeting of seawater and freshwater. The facility, which began operating on August 5, will produce around 880,000 kilowatt-hours annually, powering a desalination plant and marking a milestone in renewable energy. Experts see it as a crucial development in the search for renewable energy sources that can function continuously without weather limitations or carbon emissions. Instead of supplying homes directly, the output will be channeled into a desalination facility that provides clean water to residents of Fukuoka and surrounding areas. The agency highlighted osmotic generation as a next-generation renewable energy source that is not affected by weather or time of day and emits no carbon dioxide. By relying on the natural flow of water molecules across a semi-permeable barrier, the technology avoids the intermittency problems faced by solar and wind power, which depend on sunlight or favorable weather conditions. The science behind osmotic power. The principle of osmosis, known to science for centuries, is at the heart of the system. When freshwater and saltwater are placed on either side of a semi-permeable membrane, water molecules naturally flow toward the saltier side to balance concentrations. Osmotic power plants exploit this process by placing two water streams with different salinities opposite each other, separated by specialized membranes that allow only water molecules to pass. As the freshwater crosses the barrier, pressure builds on the saltwater side. This pressure is then used to drive a turbine connected to a generator, producing electricity. The concept is straightforward but technically demanding. Large amounts of water must be pumped into the system, and membranes must withstand high pressure while maintaining selectivity to avoid impurities passing through. Why this was a long time coming? Although osmotic energy has only recently reached commercial-scale implementation, the idea itself is not new. The theoretical foundations were laid in the mid-20th century. In 1954, researcher Patel first suggested that the mixing of freshwater and seawater could be used to generate power. In the 1970s, Professor Sidney Loeb, best known as co-inventor of reverse osmosis desalination, developed the method known as pressure-retarded osmosis, PRO, after observing the natural mixing of the Jordan River and the Dead Sea. Since then, multiple attempts have been made to move the technology from laboratory prototypes to viable energy plants. Thank you. Please subscribe and share the video.